Dober dan in lep pozdrav vsem udeležencem. Dobrodošli na današnjem webinarju o novem tiskalniku podjetja Formlabs, torej po tiskalniku Form 3L. Za začetek naj vam predstavim današnjo ekipo, torej ekipo, ki bo danes z nami. Torej, z nami je Miloš Jovanovič, predstavnik podjetja Formlabs. Z nami je tudi Doberov Jakob, prav tako iz podjetja Formlabs. Potem je moj sodelavec v podjetju IB-CADDY Rok Vojska in še moja malenkost Rok Žabkar, torej tudi iz podjetja IB-CADDY. Torej naj zdajle še omenim, da če želite o tiskalniku izvedeti še kaj več, se nam lahko pridružite na virtualnih sestankih, ki jih bomo imeli v kombinaciji s podjetjem Formlabs, kjer bomo govorili lahko o njihovih produktih, torej tudi v manjši skupini. Torej, vi, predstavnik podjetja IB-CADDY in predstavnik podjetja Formlabs. Več o tem bomo povedali na koncu webinarja. Torej, poglejmo si zdaj še današnjo agendo, torej začeli bomo z uvodom. Pogledali si bomo tiskalnik 3L, pogledali bomo materiale, ki se lahko uporabljajo v tiskalniku 3L in nekako aplikacije, ki so primerne za te materiale. In na koncu bomo zaključili z vprašanji in odgovori. Naj na hitro še predstavim naše podjetje. Torej, ustanovljeno je bilo leta 1991 v Ljubljani, kjer je še vedno sedež podjetja. Torej, v Kamniku imamo IB-CADDY ITC oziroma izobraževalno-tehnološki center, kjer imamo tudi naše 3D tiskalnike. Torej, tam je nekako naš showroom, naš predstavitveni prostor za 3D tiskalnike. Imamo pa tudi pisarno v Beogradu v Srbiji. Ukvarjamo se s široko paleto rešitev za industrijo, torej ukvarjamo se s CAD-om, torej SolidWorksom in različnimi rešitvami, ki so vezane na to okolje. Sem spadajo recimo CAM, PDM, različne vrste analiz in druge. Ko govorimo že o softwareu, imamo tudi lasten razvoj za posebne aplikacije. Ukvarjamo se pa tudi z 3D skenerji in seveda ukvarjamo se tudi z 3D tiskom. Torej, med drugim ponujamo tudi tiskalnike podjetja Formlabs. Sedaj pa bom besedo predal gospodu Milošu Jovanoviču, ki bo povedal nekaj o podjetju Formlabs in o tem, kako podjetje Formlabs sodeluje v boju proti koronavirusu. Torej, Miloš, če lahko kar prevzameš.
Hvala lepa. Hi everyone. I would like to give you a warm welcome for joining us today and taking a bit of your time out of this day to listen to us. My name is Miloš. I've been with Formlabs for more than 3 years now. I would just like to give you a small overview of, if you don't know, what Formlabs is doing, who we are, and where we are going. And yeah, as Rock mentioned, a slight update of what we are doing to fight this COVID pandemic. But first things first. So basically, yes, we are manufacturer of 3D printers in shortlist. In a bit more details, we are trying to democratize the 3D printing world completely by making desktop, what was started as focused on SLA printers, now grew and is growing significantly. But we started humble in 2012 with Max Lubowski designing the first prototype in his basement, putting it out as an idea on Kickstarter, and that kind of blew big time. Instead of 3 printers, that was the goal, or 10, we have more than 1,000. But really, 2012 for us was a game changer. Then 2014 with something more that everybody knows as Form 1 Plus, which really gave us the possibility to penetrate the market more, as we would say. So we become more known in Europe, Asia Pacific, and all over the place. But when I say to democratize the 3D printing, what was always in our DNA is to make the affordable 3D printers. So basically, it's really accessible, so everyone can make anything. Anyway, we are trying to do that even to this day. So when we switched from Form 2, we said, hey, okay, everything that was really good on Form 1 Plus, cool, we'll keep it. Anything that we can improve, let's see, and let's find a way. And Form 2 for us, 2015 was big year as that. And a couple of years after, I think globally we have more than 50,000 printers shipped and delivered to the customer with more than 50 million produced parts. And then fast forward 2019, when we announced the latest, and what Rock will talk more in details in a few seconds, the LFS technology, so bit again upgrade of what we did with stereo force lithography. I will never know how to pronounce this name properly. Yeah, and announcing the fully biocompatible printer, 3D printer, and the Form 3L, the big volume, the one we are going to discuss today. So in short, you have the numbers. I am dyslexic, I hate numbers. So hopefully you all read that while I was talking. So we can go to the next slide, where I think is the main point for us. Yeah, it's not the news. We know the COVID is here to stay, and it's been a while, almost a year. But I just wanted to touch base on what we as Formlabs are doing to fight it and to help fight the COVID. But also there are two, I think, major things that are hidden that are really highlighting 3D printing as its best. We can go to the next slide, please, and I will try to explain all of it. Thanks. So several things we did since the day one. We made a short pivot and decided, okay, we want to do something meaningful. We want to help. How we can do it? So we have 3D printers. We can make anything. Cool. I would like to focus on the nasal swabs because this is the main point. So when things started to progress on worse, you realize that really demand and supply is something that is holding us down for a long time now. And if you consider the nasal swab, the testing kits that are out there, there is limited possibility how you can outsource them, especially in the global crisis like this one. That means at some point the manufacturing has to stop or you hit the bottleneck. And then you say, okay, we have 3D printers. What we can do? We can print them. Really good. So we basically shut down our entire printing facility for sample parts, prototyping, and said, okay, day in, day out, we're producing the nasal swabs. Next to them, yes, there is the ventilator splitters, the BPAP adapters, the fast diagnostic kit, the divisors that you all know, and adapters for the diving masks. But the nasal swabs, for me, is epitome of what 3D printing is all about. So basically, in matter of hours, not days, not weeks, not months, you can make a decision. I'm engineer, and this is how I was taught. If you don't like something, you change it, you make it happen. We made it happen. We can produce our own stuff. And then the second part that is really cool about 3D printing to me personally is if it doesn't work, you change it, you adjust it. So what happened when with the nasal swabs, we start producing it, the USF, the hospital in US started doing it. The Spanish hospital adopted the designs as well. We had a big facility in Portugal, then Singapore kicked in and so on. So at one point you have millions of parts being produced on a daily basis, but not all of them fit right. So there is no one should fit, not one size fits all. And then depending on reagents that you use, we discovered, okay, there are several other iterations of design that we can use to cover more epithel, for example, and you get more accurate reading and test. And this is the beautiful part. In a matter of hours, you can do redesign, reiterate, test it, and next morning you have hundreds of thousands of kids going out and helping people fight the COVID. So this is all for me in short. We will touch point on this more. We will have a dedicated webinar on biocompatible and 3D printing in medical mostly. So we'll go more in all of this into details and what we as Formlabs are doing, the broad range of materials that Jakub will also touch base today. But basically just to say hi, to give you a slight glimpse of what is coming and what we're doing, and then Rock can explain more in details about the technology. So thank you.
Thank you, Milos. Can you maybe do you have any idea how many nasal swabs you printed? Do you have any idea?
Roughly, yes. I think only our production facility, we did 100,000 pieces on weekly basis. But that is not taking into consideration any other facility that was doing. So the really good cool part about Formlabs is that it's scalable. So with one printer, you can make 100 pieces, but one is same as 5, 10, or 100 and 1,000. So we're talking about 1 million printers on almost a weekly basis globally.
Wow. Okay.
Yeah.
Thank you. Torej, hvala Miloš. Sedaj bomo pa predali besedo mojemu kolegu Roku Vojski, ki nam bo pa predstavil tiskalnik, ki smo ga danes prišli pogledati, torej Form 3L. Rok, če lahko kar prevzameš.
Hello?
Okay.
Ja,
okay.
Okay, super.
Te imamo. Okay.
Evo, en lep pozdrav še z moje strani. Zdaj skratka, za Forum 3L, kje se je vse začelo? Vse se je začelo v bistvu aprila leta 2019, kjer je v bistvu Forum Labs preoblikoval to tehnologijo stereolitografijo v stereolitografijo z nizkimi silami, ki jo oni imenujejo pač Low Force Stereolithography, s kratico LFS. In v bistvu, zakaj so to storili, je, ker s to tehnologijo doprinesejo veliko novih prednosti. Ena izmed teh prednosti je izboljšava na sami kvaliteti natisnjenih kosov, se pravi, manjše podrobnosti so bolj izrazite, površina je bolj gladka, pri prosojnih materialih so bistveno bolj prosojni, sam proces tiskanja ter tudi sam tiskalnik je v bistvu enostavnejši za uporabo, tako da je zelo prijazno samemu uporabniku. Samo vzdrževanje je absolutno minimalno, zanesljivost pa bistveno višja, tako da v bistvu sami printi imajo višjo možnost uspešnosti, tako da bi rekel, lahko, ko poženete tisti print, lahko vmes ponoči spite, ker veste, da bo naslednji dan ta vaš print natisnjen in lahko v bistvu s tem potem nadaljujete. Same izboljšave tudi pri postprocesiranju. Zaradi te tehnologije so stiki podpore ter vašega kosa bistveno manjše in zaradi tega lahko kose zelo enostavno pa hitro dodelate. In kar je v bistvu ta tehnologija tudi Forum Labsu omogočila, je, da lahko Forum Labs razvija nove materiale, ki jih na prejšnji svoje SLA tehnologiji niso mogli uporabljati, ter tudi je to omogoča, da lahko tehnologijo oziroma te naprave s to tehnologijo skelirajo, da lahko izdelajo večje tiskalnike in tako je prišel v bistvu naš ta Forum 3L in njegova različica Forum 3BL. Evo, tukaj v bistvu vidite to tehnologijo v procesu. Spodaj je LPU enota, to je ta, ki vsebuje ta laser, ki utrjuje material. Material je tekoč in je na osnovi smole, zato ga ta UV laser utrjuje. Vmes je rezervoar s tem materialom. Tukaj je prozoren, zato se tako lepo skozi vidi in v bistvu ta tehnologija nam to omogoča, da so te sile, ker se mora kos ločiti od tega rezervoarja, so bistveno manjše in zaradi tega lahko doprineslo to tako veliko novih teh prednosti. S Forum 3L pa tudi, kot sem omenil, prišla biokompatibilna različica Forum 3BL. Ta Forum 3BL pa v bistvu omogoča, da lahko tiskate z biokompatibilnimi materiali, ki se jih lahko čisti tudi v avtoklavih, tako da je odlično za medicinsko industrijo. Kar je v bistvu Miloš prej omenil, v bistvu s temi biokompatibilnimi tiskalniki, ki podpirajo biokompatibilne materiale, so lahko zdaj v bistvu tako zelo velik vpliv naredili na svet. Zdaj samo stanje na trgu, kar se tiče nasploh tiskanja kosov, velikih kosov iz SLA tehnologijo. V večino primerih je treba te kose dajati ven drugemu proizvajalcu za narediti in so lahko zelo dragi, pa tudi vzame kar nekaj časa, da ta kos pridobite. In v bistvu na trgu, če pa želite vsi kupiti tiskalnik, pa v bistvu obstaja kar velika luknja na trgu. Imate na voljo ali nizkocenovne, samo tudi nizkokvalitetne tiskalnike z SLA tehnologijo, ali pa visoko kvalitetne, vendar so potem s tem tudi zelo dragi. Formlabs s svojim Form 3L pa je ravno nekje vmes, kar se cenovnega vidika tiče, s tem, da ima še zmeraj vrhunsko kvaliteto natisanih kosov. In tako imamo na voljo zdaj tega Form 3L, ki v bistvu ima petkratni volumen Form 3, čisto tako za primerjavo. Tole je delovni volumen Form 3 tiskalnika. Tukaj, tukaj zraven, imam pa delovni volumen Form 3L. Tako da v bistvu volumen je bistveno večji za kar petkratnik, pri katerem je tudi dvojna moč laserja. Evo, pa kot sem omenil, v bistvu še Form 3BL različica, kar se tiče tehnologije, je identična s tem, da ima dostop do biokompatibilnih materialov. Evo, in v bistvu, s tem, ko si, bi rekel, lastite velik SLA tiskalnik, kakor je Form 3L, kaj s tem v bistvu vi pridobite, da prvo kot prvo ne boste več rabili kose dajati ven delati, ne boste več rabili čakati na te kose, točno boste vedeli, kdaj bojo narejeni in v bistvu bistveno pospešite ta vaš proces dela. Kosov tudi ni treba več razrezati, zato da bojo šli lahko noter tiskalnik, ker imate tako velik volumen, velik format, lahko kose natisnete v naravni velikosti in se izognete temu rezanju. Ter seveda tudi perfekcionizem, ki v bistvu vedno raste. Formlabs konstantno izboljšuje programsko opremo, tudi samega tiskalnika, tako da sčasoma so printi vse hitrejši, pa vse bolj kvalitetnejši. Sama uporaba tiskalnika je zelo enostavna, ne potrebujete imeti specializirano osebo za to, kajti tudi sam tiskalnik in sam proces, kako uporabljati tiskalnik, vas lepo vodi, ter tudi vas opozori, če ste na karkoli pozabili oziroma če ste na karkoli spregledali. Tako da tukaj napake so minimalne. Prav tako imate avtomatizirano nastavitev tiskanja v smislu v programu, kjer se pripravi vse samodejno, orientacija, podpore. Tudi samodejno se potem to lahko naloži tudi na tiskalnik, kjer lahko tiskalnik tudi poženete nadaljavo, tako da v bistvu ne rabite biti ob tiskalniku, da poženete tisk, lahko ga tudi nadaljavo. Ter seveda Formlabs pa omogoči vsem uporabnikom odlično podporo, tako da so pa tudi premium načrti, ki pa doprinesejo še določene prednosti. Se pravi, lahko tiskate brez zamude, sam nadzor tiskanja imate v oblaku, imate platformo na spletu, na vašem računu lahko sledite točno, kaj ste printali, kdo je printal, na katerem tiskalniku ste printali, koliko kilo imate materiala, se pravi, vsemu lahko sledite, tako da lahko bolje načrtujete naslednje korake. Formlabs ima na voljo tudi material za hitro tiskanje, v primeru, če želimo zelo hitre prototipe izdelati. Material se imenuje draft, sive barve in ima tudi zelo lepo gladko površino in s tem v bistvu zelo prihranite na času. Potem pa seveda je zaradi načina, kako je tiskalnik sestavljen, imate sama popravila tudi na terenu. Ni treba tiskalnik vedno pošiljati ali dostavljati. Lahko nekdo serviserjev pride k vam in v bistvu odpravi napake. Samo upravljanje z materiali je zelo enostavno. S tem, ko je kartuše, material se samodejno dozira v tiskalnik, tako da vam ni treba ročno dolivati materiala. Prav tako, pa kot sem omenil, na platformi v oblaku lahko sledite točno, koliko materiala imate. Tudi tiskalnik vas bo opozoril, če materiala primanjkuje. Če ga materiala slučajno zmanjka med tiskom, ni problema. Printer tiskalnik bo počakal, dokler da boste dali nove kartuše noter, polne, in bo se print nadaljeval. Zdaj si bomo pa pogledali proces samega 3D tiskanja in v bistvu je razdeljen na 3 korake. Prvo je oblikovanje in priprava vašega modela ter priprava naloge tega printa, katerega lahko pošljemo na 3D tiskalnik tudi preko Wi-Fi omrežja. Zatem sledi tiskanje na samem tiskalniku, kar si bomo tudi zdaj pogledali, ta še postopek, ter seveda potem po tiskanju pa treba še te kose postprocesirati, se pravi, jih je treba še očistiti, treba se znebiti tega nestarejenega materiala, ter kose dodatno utrditi v UV pečici, zato da pridobi te svoje materialne lastnosti. Evo, dalje. Si bomo pa tole. Zdaj bomo šli pa na Preform v program. Evo, sedaj se nahajamo v Preform programu. To je program, v katerem v bistvu mi pripravimo naše 3D modele za printati, se pravi, izberemo tukaj na desni naš tiskalnik. Že tukaj vidimo kartuše oziroma koliko materijala imamo še v kartušah, trenutno jih še nismo ustavili, prav tako še nismo ustavili rezervoarja. Tako da izberemo tiskalnik ter tudi resolucijo, s katero bomo tiskali, ter seveda tudi material. Ko to izberemo, vstavimo naš 3D model, naš model lahko prosto rotiramo in seveda pač po nekih pravilih je treba to potem ustrezno pripraviti. Tukaj pa tudi vidimo, tale srednja črta v bistvu prikazuje te dve enoti, ki v bistvu istočasno utrjujeta material. Se pravi, sta dva laserja, eden tukaj na zgornji strani, ene pa na spodnji, in delujeta istočasno. Tako da, skratka, ko mi naš kos orientiramo, lahko tudi uporabimo funkcijo za samodejno orientiranje. Po orientaciji pa generiramo podpore. To tudi program naredi samodejno, kar imam v bistvu tukaj že tako pripravljen in to v bistvu takole izgleda. Kar pa je tudi super, je pa, da mi lahko te podpore ročno tudi popravimo, če je to potrebno. Skratka, in ko imamo kos pripravljen, ga postavimo na željeno mesto, lahko jih tudi dupliciramo, pomnožimo in zadnji korak potem je pa, da to pošljemo na sam tiskalnik preko Upload Job. Tako da preko Wi-Fi ali USB je tako več možnosti. Evo, no. Zdaj si bomo pa ogledali, kako pripraviti sam tiskalnik. Tako da tiskalnik, da lahko obratuje, potrebuje 3 komponente in to so rezervoar, delovna platforma pa kartuše. Prvo, vedno kar ustavimo, takole v bistvu spremo tiskalnik lahko. Prvo, vedno kar ustavimo, je tole naš rezervoar, naš resin tank za Form 3L. Vsak material potrebuje svojega in v bistvu je zelo trpežen, zdrži zelo dolg časa, več litrov lahko tega predela in bo še vedno lahko uporabi. Tako da je zelo enostavno, mi samo tole postavimo noter v tiskalnik in porinemo do konca. In že sam tiskalnik potem zazna, da je notri neuporabljen rezervoar. Naslednji korak je pa delovna platforma. Na delovni platformi se tiskajo naši kosi, tako da tukaj gor se naši kosi primajo in s tem moramo potem tudi te naše kose odstraniti. Recimo v primerjavi s Form 3 je to take velikosti, tako da res lahko vidimo, kakšna je ta razlika, kakšna je to v bistvu ta sama velikost. To tudi zelo enostavno ostavimo, klejle ročko dvignemo in primerjamo do konca in zapremo, kar tiskalnik tudi prav tako zazna. Evo, to je to, mi to enostavno zapremo. Tale oranžna akrilna površina pa ščiti material pred UV svetlobo, tako da je v bistvu tudi, če nas več dni ne bo, printi naši lahko nas počakajo tukaj notri, se ne mudi po printu to vse vzeti. Kar nam je še ostalo, je pa material, tako da tiskalnik potrebuje 2 kartuši, zaradi tega, ker potrebuje toliko več materijala, da lahko printa. In oboje tukaj lepo ob strani lahko vstavimo brez težav in v bistvu to tudi vse naš tiskalnik zazna. Prav tako nam potem to javi na Preform programu, tako da vemo, kje materijale točno imamo not, kjer material je v bistvu v kartušah, pa kjer material je v rezervoarju. Tako da tiskalnik je pripravljen, to lahko tudi preko oken zaslona preverimo, da je res vse ustavljeno, kar tudi sam tiskalnik preveri. In lahko preko naše tako veliko čakalne vrste, naše zgodovine printov, lahko pričnemo ta naš novi print ali pa lahko tudi kakšne stare ponovno poženemo. Tako da v bistvu, ko se naloga iz programa, iz računalnika prenese na tiskalnik, ni potrebne več povezave z računalnikom, lahko tiskalnik dela na svoje. Tako da to je, kar se priprave tiče. Ja, hvala. To je, kar se tiče priprave. In s tem, tako da v bistvu potem samo poženemo print in po printu nam pa ostane samo še postprocesiranje. To postprocesiranje pa nam pomagata 2 enoti, in sicer Form Wash in Form Cure. Form Wash je za čiščenje kosov, da se znebimo te nestrjenega materijala. Ko se pa kosi posušijo, se jih da pa v Form Cure, v UV pečico, kjer se pa te kosi potem utrdijo, da dobijo te svoje maksimalne te materialne lastnosti. To je specifično pomembno za inženirske materiale, kar bo pa tudi Jakob več povedal o tem. Tako da to je to iz moje strani.
Ok, hvala Rok. Samo hitro vprašanje, ti si zdaj noter v tiskalniku stavil tank, dal si tiskalno ploščo, pa dodal material. A je to torej, zdaj je potem pripravljen tiskalnik za print, a je?
Tako, ja.
Ok, torej hitra priprava samega tiskalnika, ne?
Ja, samo te 3 komponente je treba paziti, da jih pravilno ustavimo. Ostalo, kar se tiče pa vzdrževanja, pa to pa praktično pa ga v bistvu ni. Je tako lepo zasnovan s to novo LFS tehnologijo, da uporabniku da več pozornosti lahko na druge stvari, da se ni treba to ukvarjati s samim tiskalnikom, da bo v redu naprintal, ampak da lahko ta svoj čas zapravi za druge zadeve.
Ok, hvala Rok.
Hvala.
Ok, zdaj se bomo pa obrnili še na na naslednji pač odsek naše predstavitve, kjer bomo govorili o zelo pomembni temi. Torej, govorili bomo o materialih. Torej, če govorimo o printerju, še tako dober printer ni vreden nič, če nima dobrih materialov, s katerimi bomo mi naredili izdelke. Torej, materiali so torej tisto, iz česar mi potem naredimo tisto, kar mi želimo. Ta del bo pa prevzel Jakob. Okay, Jakob, if you could tell us something about the supported materials on the Form 3L.
Sure. And for this, I think you can already.
Yeah, I have spotlighted.
That is. Thank you very much. Yeah, hi everyone. I'm Jacob, also of the Formats team, just along Milos. I'm with the team for a bit longer now. I'm with the team for it's going to be 5 years in 3 days. So quite a bit actually with the company. It was a bit funny because when I started, I was the 7th employee in the Berlin office, and now we're a little bit over 150. So that has been quite the growth, and a particular place we have been growing in, not only the printers themselves, as Milos has shown you a little bit before, but we've also greatly increased the range of materials that we had. So back when I started, we had 3, the clear, a flexible, and the castable material, and then I think the white and black came closely after, but now it's over 20. But I don't want to just read off a spec sheet to you or like show you a couple pictures on the slides, because I'm very much of a person that likes to touch things and like see how they work that way. So I'm going to switch cameras to my little table that I have over here, and I have almost all materials available to us right here. And I just want to go through all of them one after another with you and show you the different things that we can do. Let me just zoom out a little bit, and then I'm gonna just grab them one by one and show them one after another. So Milos has talked about it a little bit. I just want to mention these real quick. So there are quite a few biocompatible resins. Some, like this, is the Dental SG version. So this is biocompatible, this as well. And you can do things like in the dental industry, or you can go the route of doing anything that has to do with like these swabs, for example, and all of those kind of things. And there is also quite a bit of research and development, but I don't want to go too much into those. As Milos also alluded to, there's going to be a specific webinar specifically for the biocompatible resins and all of that comes along with it. So then let's start out with what we refer to as the general purpose or standard resins also, which we have in 4 different colors, or let's say 3 different colors, and one then is clear. Where we just have a standard black, white, and a gray color to all of these. These are just general good resins that are nice and stiff for just general prototyping. And then you can use these to do all sorts of things, like these pens, for example, and stuff like that. But if you're using specifically, and this is my favorite of all 4 of these, the clear resin, what I really like about it is that you can also use it for things like a fluid simulation, like this one. But if you go over to also taking sandpaper to it, or something like a polishing paste, for example, and this is just any kind of, this is in German right now, sorry, because I'm from Berlin, but you can use any kind of general acrylic polishing paste for this. And then you can use the clear resin to make things like light channels or lenses and things like that. So these are also pretty neat ones that I made a while ago. Or if you don't want to go the route of polishing these up, you can also just use, and this is what I did here, use an acrylic spray on top. Of course, the clarity is not as nice as in the one that is polished, but of course you can see that this is a thing that takes maybe 2 or 3 minutes to do, and then you can arrive at an almost glass-like finish. So those materials are pretty great for your everyday standard prototyping or just making general use parts. These are very stiff and can hold quite a bit of force. But the one thing that they don't give you is a lot of flexibility. And that's where we specifically go into the more flexible materials. So this is the range of engineering materials that we have, where we have them as and as these. I can actually put this aside for now a little bit. So these are the first few. So this is the tough 1500 material. So this is very specifically made to have a lot of flexibility. So if you need to do like something like these clip-in hooks that don't need to spring back immediately, or something like the spring here, for example, this is an excellent material to do these kind of things. I've also seen some people do stuff like living hinges with this, but there is another material that is much better for that. But this would be the tough 1500 material, which you can also use for enclosures, especially if you have something that sometimes needs to take a hit and then not immediately break. That is a very nice material to use for that. A little bit nicer for doing enclosures is actually the tough 2000 material. This is quite a bit more stiff than the tough 1500 one, but it's not so stiff that if you hit it with a hammer or something, it's going to immediately shatter, which would be more like the reaction of the standard materials. But this can actually flex quite a bit. And this is my favorite material for making things like, so this is something that I made. So this is a solenoid holder for a keyboard. So something like these clip-in hooks, which I really like to do with a tough 2000 material because it just snaps back really nice and really satisfactory. So this is a very nice to use general purpose kind of resin if you want to have something that is stiff, but then can flex in some specific instances if you're doing something like this, for example. And of course, as the others have shown you, the material change is very, very simple. So it's also very easy to just also go back and forth in between materials and then combine them with other things. Even a bit more stiff than the tough 2000 would be the Grey Pro material. So this is one that doesn't flex a whole lot. There is basically the difference. I mean, for the tough 1500, you see it very clearly how different it behaves. But for these two, it's more in the actual tech specs, in the flexural modulus, in the elongation until break. So we have these very specifically lined up, so you can choose specifically what you need in terms of the application. So this, for example, is like a lever that is printed in the Grey Pro, like a snap-in lever for like a fast retention arm. So this is something that needs to take a little bit of force for a couple seconds or maybe a minute, and then it would hang in a specific position. So this is also a very nice resin to use back and forth with the tough 2000, depending on the application that you want to have. If you want to go a bit more special, and actually let me push these aside because this is just a little bit more on the side of the standard resins. This is unfortunately a resin which we just reformulated. So this is the draft. In this case, it's the draft version 1 resin that I still have here. Unfortunately, I do not have the draft version 2 yet, which is the reformulated version of this resin. But for SLA prints, one of the nice things is that as opposed to other 3D printing techniques, you see these layer lines only really if you have something like this stepping up here for a curve like this. But apart from that, even on the 0.1 millimeter layer setting, you don't really see those layer lines. Well, on this material, you can see those again. I think my camera's, you can see them a little bit. My camera is not picking them up all too well, unfortunately, but you can see those layer lines again. Well, that's because the draft resin is printing in much thicker layer heights. So this was the old version that printed in 300 microns. The new version, which has more of a dark gray color, more in lines of what the tough 2000 is right here. So the new material is a gray color and not this bright blue color. And it will print in 200 micron layer heights, which makes the whole thing just print much faster. So these two, for example, we're going to talk about this material in a second here, but these two, if you print it in the draft resin, this whole retention arm that we have here, this will, so this is more of a bracket, sorry. So this will print about 2.5 to 3 times as fast, also depends a little bit on the orientation, but this is the big advantage. So if you just need to make a rough first draft, and that's specifically also where the name comes from. You just want to test piece, you just want to test piece and see if it fits, and if you measured everything correctly, then the draft resin can be a very good time saver for this. This is also something where a lot of people also use the draft material to do thermoforming. So especially if you want to do like a packaging or something, the draft resin can be something where you can make big bulky parts very, very fast. And it also helps you, especially on the Form 3L, as the printer itself is so humongous. If you use the draft resin, you can speed that time up again a little bit. And even though you have massive prints or you have a lot of models, just like Rock showed you before, you can end up with pretty reasonable times on printing. So while I have this in my hand, let's talk about this. So this is the rigid material. This is specifically the new reformulated rigid 4000 material. So this is a material that has a glass powder inside. So it has very specific properties in terms of what it can do, in the terms of optics. So if you need to do an enclosure, let's say, and you have a couple of LEDs on the inside that need to shine through and give you some indicator, like some status LEDs of an electronics board, for example, then this can be a material to specifically use for that. Apart from that, it has very, very nice soft surface finishes just due to the glass powder that is inside. So if you want to do any kind of aerodynamics simulation, or you want to print a little turbine blade for a pump or something, then the rigid material can be a very great fit. This is a super stiff material, so it doesn't really bend all that much. So the elongation until break for this is about 5%, which is quite good. So this, instead of bending and starting to break at some point, this will stay the way it is and then break and more shatter as a failure point, basically, at some point. So this is also a material that is very good for like these kind of bracket types of applications. There is one which I also don't have yet because we just released it about 2 weeks ago, which is the rigid 10K material, which is even stiffer than this one. So the new rigid 10K material is very similar to this, but it goes more in the range of even going so far. I don't want to say a ceramic-like material, but it really goes in that direction. So the rigid 10K is one that has an elongation of only 1%. So this is very nice for doing something like sensor holders and things like that. So things that really need to stay in one place and specifically in that one place. And for the rigid 10K material, it also goes up to 170 degrees in heat diffraction temperature. So that is a very nice resin to use for that application. And speaking of heat deflection, we also made a resin specifically for that, which is the high temp material. So this one is specifically made to be in high temperature environments. So this is like a nozzle for a Bunsen burner, but also people are doing like molds with it for doing PP or PE injection molding. Or also silicon, because this material can go up to 238 degrees Celsius. Another very nice application for this is any kind of jig or fixture that you need to have for a soldering process, for example. So you can make little clamps for grabbing like any kind of electronics that you then solder something onto, like SMC components, and that can be a very, very great fit for these kind of applications. So this is the great strength of SLA and LFS technology, that we can do materials with all of these range of materials. Also, I forgot, so let me just pull back the TUF 1500 material. So this is a very nice comparison to our durable material. So this is also a more softer material. So this can do things like these clip-in, like joints, for example. So this is a very nice material to do this kind of stuff too. And these are actually very, very close. You can see that they have a massive difference in terms of their color. But basically the difference in between the two is that the TUF 1500 was more made to simulate polypropylene properties, so basically PP, and the durable material would be going more in the range of PE-like materials. So this can simulate those mechanical properties pretty well. And if you sand this down, or if you give this a little polish, you can also get these super nice low friction surfaces and do something like a little rail where you can slide other pieces into. So that is a very, very nice material for this type of application. if you want to go into that whole spiel with the flexible materials, but these are not giving you what you really need and you want something that is actually really completely flexible, then what you can go for are the two materials that we specifically have in the flexible range. So this one that I have right here would be the flexible ATA material, which is a nice rubber-like material. So you can use this to make something like the script that I have right here. And you can also see that even though it is a flexible material, it is still capable of printing super fine structures like this, which is something that other 3D printing methods, when you're working with flexible materials, severely lack. It can be a big hassle to work with flexible materials in the first place, but you can see that SLA and LFS technology can still do these super fine features of things like these. So this is a very nice grip for a rubberized surface. So this is what the flexible ATA material can be very, very nice, especially if you combine it with any of the other materials. So let's say you have an inner piece that is maybe tough 1500 or the durable material like any kind of joystick or so, and you want to give it more of a nice haptic to it, then you can use the flexible as a sheet on top of those materials. But if you need to go more in the range of silicones, then what you can do is use the flexible 50A material. So this piece is still with its supports on it. So this is also for simulating basically human tissue. And then you can also see that it varies quite a bit on how thick the material is. So in these more thin parts, you can see that it's easy to bend these. And then the thicker parts, just as silicone would behave, it's a bit harder to bend these over. And then for the support material, you can see that these also very nicely bend out of the way, and then it's easy to clip these off, basically. So this would be for any kind of seals or gasket that you want to try out and see if everything fits correctly and if it works, and then you can very nicely use the Flex 50A material for this. And those two designations would be the shore hardness of those materials. So the ATA, so 80A material would be a shore hardness of 80, and then the flexible 50A, of course, has a shore hardness of 50A. And last but not least, the one material that I left a little bit out here, it's more in the jewelry industry, but this would be our castable wax material. So this is one that is specifically made for a casting process. So for this, you would basically print your active and then put it into a mold, basically into a plaster, and then mold it in there. And then in an oven, you can completely burn this material out. So this is a material that has 20% wax in it. So this really nicely burns out without leaving any char or something behind. And then you have a cavity where you then can basically go into and do things made of silver or gold or titanium or what have you. Well, titanium you wouldn't really mold all too much. But this is also, by the way, how I made these coins here. So this is something that I designed myself. And then this would be a completely printed 3D printed piece. And then I made it in the castable material, gave it off to a caster, and had this be cast as a this is a 935 silver, so it's a bit nicer than sterling. So this would be the kind of thing that you can do with the castable wax material. And those are all the different resins, like I said, except those two for the new version of the draft and the rigid 10K. So you can see that we have quite a few applications by now that you can really pick and choose. And it's very easy to just go back and forth in between all of these applications, depending on what you're doing at the time. So with this, let me go back to the other camera. And I think that would be mostly it from my side on the material.
Okay, thank you, Jakob. Can I just a quick question for you? You showed us a lot of materials right now. If someone were deciding to buy a Form 3 or Form 3L and wanted to print with durable, can they see how long a print of their model would take, how much it would cost, and things like that?
Yeah, and there is actually a pretty easy way to do that. And this is something that I would generally tell everybody to do when you're thinking about getting one of our printers. And Rock really nicely showed you our Preform software, and that is something that is free. So you can just go to our website, just formlabs.com/software, or you can just go to formlabs.com and click on software at the top. And you can just download Preform. Then you can use your STL or OBJ files, which you can export from SolidWorks, Fusion 360, Inventor, and everywhere else. You just save those, and then you can import them into Preform. You can use the software to just see already how easy it is to change things like the orientation and the support. And on the top right, you will be able to see a little printer info, and there you will see how long approximately the print will take, plus minus 10–15%. I usually tend to tell people, but then you can also very easily see how much resin these individual pieces would take with or without supports, and then you can calculate up from that how much the piece would cost and if this is something you want to get into.
Ok, thank you, Jakob. Ok, torej sedaj se bližamo koncu našega webinarja. Naj samo še enkrat opomnim, da vas vabim, da se nam pridružite na naših virtualnih sestankih. Torej, to bodo sestanki med vami in predstavnikom podjetja Formlabs in predstavnikom podjetja IB-CADDY, kjer se lahko prijavite, torej na linku, ki je prikazan tukaj na tej naši strani. Torej, tukaj se prijavite, mi bomo stopili v kontakt z vami, uskladili bomo termin in potem boste dobili povezavo do sestanka, zelo podobno, kot ste dobili povezavo do današnjega webinarja. Torej, poleg tega pa se nam sledijo še nekaj webinarjev, torej specifično 3D SLA tisk v industriji, torej to bo v torek 17. 3D SLA tisk za zlatarje v sredo 18. in v naslednji torek, torej 24.11. bo 3D tisk z biokompatibilnimi materiali. Če slučajno koga zanima, torej identičen webinar bomo imeli tudi še v hrvaškem jeziku, torej to bo čez en teden v četrtek in potem še 3D tisk v industriji še tudi v hrvaščini. Ok, se vam bom zahvalil za vašo udeležbo in kot sem rekel, vabim vas na naše virtualne sestanke in na sledeče webinarje. Najlepša hvala. Thank you very much, everybody.
Thank you. See you soon.
Bye.
Goodbye.